Hello, everyone. I will take the opportunity to welcome you all in the subject Application of Soft Computing. Myself, Dr. Shruti Gupta, Associate Professor, CSC Department. Today, I tell you about the basic introduction in the soft computing. So let's proceed ahead. So if we are looking about the contents, we have first concept of the computation. What is computation? We will discuss about that. Then the concept of the hard computing, then soft computing. Then we will differentiate between this hard computing and soft computing. And the last one is a hybrid computing. So first we're talking about the computing. Whenever we start anything to work on a project, working on any system technology, our aim is it should be a task oriented. For the task oriented, we have two things in our mind. First, the input, and second one is output. So in a computing, antecedent and consequent, these are the two terms are used. The antecedent is a term used for your input provided, and the consequent is used for the output provided. In mid, we are able to see that flow diagram in which we are passing some sort of the inputs and we will get some sort of the outputs based on the equation y is equal to fx. The x is a basically input, the number of variables and number of inputs we are giving to the function. Based on them, we received some output y. Whatever the value of the x we are providing, we are receiving the value of y. So this is the basic concept of the computing. So next term is hard computing. So hard computing, if I'm talking about the hard computing, it's term coined by the father of soft computing, L. Zadar. So he defined the term hard computing. Hard computing is totally traditional computing where we have a sort of the steps, continuous steps. We have an algorithm, we have a mathematical model. We have to focus on the precise result that result should be obtained. We have a steps, that's why we followed some sort of algorithm, it followed some sort of the mathematical combination. It precisely stated the analytical model that basically takes a lots of time in the computation. So it's a concept of the hard computing. Everything is performed in the control action and it's unambiguous. So this is the basic features we formed for the hard computing. If I'm talking about the various example, the first one is a numerical problem, differentiation, integration. We have a sort of the formulas, we have to put them and we have to find the answer. We have a various sorting and searching algorithms. We have to sort, we have to search something. We have a various algorithm, insertion, sort, selection, sort. These all are example of the hard computing. Computational geometry, where we have to find some sort of the linear equality, or we have to find the where is starting point and ending point, and we have to find the shortest path. These are comes in the computational geometry. So this is the complete example of the hard computing. Hard computing, if I'm talking in terms of advantage, so basic advantage, yes, it is a very precise result. It's give me a best output. But yes, on the other side, if I'm talking about the disadvantage, it's having a lots of computational time. It takes lots of computational time. With that, it will take lots of memory, and with that, it will take lots of money. So which is a problem nowadays, because we are it's basically, if I'm computing a one line, it will not work on the real world problems that it's required nowadays in today's era, that we have to work on the real world problem. So for solving this problem, we have the concept of the soft computing. Okay, so hard computing, if I'm talking about the precise result, so definitely soft computing is totally different from the hard computing. Let's read the first definition. Again, this term is also coined by the Dr. Zadhar. They give the complete description of the soft computing. After giving the definition of the hard computing, they define the term soft computing. So first read the definition, then we will proceed with the basic terminology. So as per the definition, soft computing is a collection of methodology that aim to exploit the tolerance of for impression and uncertainty to achieve traceability, robustness, and low-cost solution. Each principle constitutes a fuzzy logic, neural computing, probabilistic reasoning. The role model of soft computing is human mind. So, if in this definition you see that I have underlined few terminologies for the defined soft computing: tolerance of impression, uncertainty, low solution. Where we are talking about the hard computing, it's totally different. The whenever we some produce some output, it's totally uncertain. It doesn't give me provide the exact solution. It should be a uncertainty, imprisons is there, and the low solution cost is present. If I'm talking about the robustness is defined in a soft computing in terms of if I will provide multiple inputs, so my system, my methodology should work on the given problem. So it will not say that I can provide multiple inputs to produce different output because it's uncertain. So for particular problem, I can have a one input, I can have a multiple input. So similarly, as an output, I can have a one solution or I can have a multiple solutions. Maybe they're having a, some different values as the output, but I have a multiple solution. And definitely it's a low solution cost because it's not following the hard regime. So its answer and the solution are towards the low solution code. The principle we obtain that from the fuzzy logic, neural computing, probabilistic reasoning. These terminologies, these complete things we will learn in the next upcoming videos. So, and the most important thing, the role model of the soft computing is our human mind. So the mind which work accordingly, we try to solve each and everything accordingly. The same concept we provide to our machine that will they work accordingly. So the role model for the soft computing is our human mind. Next, the features uh, for the soft computing. So if I'm talking about the features for the soft computing, it is imprecision. That means we don't have a predict exact output. It may contain some impurity. It may contain some noise. So it is imprecision. It's dynamic in nature. It's uncertain that well value I given some value X, and if I'm predicting for the value Y should be zero. No, it's not mandatory in the terms of soft computing. Is totally uncertain. It give me a -1 as well, it give me a +1 as well. It contains some sort of uncertainty that we consider as an error, noise. We have to optimize it later on. It's a lowest collision parts because in typical hard computing, we required some sort of the hardware-based solutions and everything based on that. The computational cost was very high. So if I'm talking about the soft computing, the solution is basically low solution cost. So the price, the total cost of the solution is very low as compared to hard computing. It does not require mathematical model. We don't fix the model that this is our model and we have to give the output based on that. Yes, we can design based on them after getting some optimized results, but initially it does not contain any mathematical model to solve the soft computing approaches. So the biggest advantage is it will well work in our real world time. We can solve many NP problems, NP hard problems, real child problems with the help of the soft computing. The main key features we can use is the fuzzy logic, neuralistic, and the probabilistic reasoning for them. So if if I'm talking about the application, let's discuss the few application in soft computing. Number one, handwriting recognition. So in handwriting recognition, character recognition, so what we are doing, we have collected a lot of ample of data. Okay, like in as the picture predicted, I take the akshar. I I have choose the अक्षर, मैंने एक अक्षर लिया और मैंने ऐसे 100,000 अक्षर ले लिया। अब मेरा सिस्टम क्या करेगा, इन सब अक्षर को पढ़ेगा और इनको पता होगा कि अगर मेरे पास ऐसा अक्षर है तो मेरे को सॉफ्ट कंप्यूटिंग ये बताएगी कि ये मेरा अक्षर लिखा है। तो अब अगर उसके पास कुछ अक्षर थोड़ा टेढ़ा लिखा आता है, ऊपर उसके लाइन नहीं होती है, या हम उसका घुमा देते हैं, की साउंड या शेप हमारी डिफरेंट है, मेरा सिस्टम उसको स्टिल रिकॉग्नाइज करने के लिए रेडी होगा। मैं उसको बहुत अच्छे से उसकी हैंडराइटिंग के रिकॉग्नाइज करेगा और मुझे वो बताएगा कि ये मेरा अक्षर था। तो हमने एक एप्लीकेशन लिया जिसमें हमने बहुत सारी हमने अलग अलग हैंड राइटिंग्स ली। अब मेरा सिस्टम अलग अलग हैंड राइटिंग्स को रिकॉग्नाइज करने के लिए रेडी है, वो मुझे पूरा रीड करके बताएगा दिस राइटिंग इज बेसिकली दिस इज रिटन इन दिस टेक्स्ट बॉक्स। ओके, सो these are the one of the application. In upcoming slides we will discuss a lot of the application on the soft computing. So if I'm talking about the how the soft computing learning is work, if in the previous slide I already told that it is my role model. Okay, so if it is human mind is role model, then how the soft computing learning is work. So I'm just telling you the basic concept where from we have the learning things will come. Okay, so first I will take the example how students will learn from the teacher. Okay, the first interaction is the from the teacher, how the students will learn from their teacher. So whenever teacher come in the class, either they give some question to the students, okay, and discuss the answer on the basis of the that. ओके, नंबर वन स्टेप कि आपकी क्लास में एक टीचर आए, उन्होंने आपके साथ क्वेश्चन शेयर करे और अब वो आपके साथ सॉल्यूशन डिस्कस करिए, तो आपको पता है अब इस क्वेश्चन का क्या आंसर है। Okay, maybe some teachers come and they give me a hint what will be the answer for that particular question, what will be the answer of this particular question. There is sort of uncertainty. Yes, it's maybe right, it's maybe wrong. So you have to identify what is the correct answer. Or the teacher will come and give you a complete notes and lecture that you have to learn this facts and this you are the learning on that. So what happened then? The students is now learning in a different manner. Either they take it from the question answer, reasoning, or some sort of the notes. Now, what happened if in the future any specific problem, any real world problem occur in their mind, or they have some steps they have want to do, they know the concept behind that. They know they have read something, they have learned something, and according to them, they can produce the new solution. They can work on that solution, they can reproduce or they can generate many solutions based on that problem. Okay, so what we did, we provide some sort of the learning in their mind. They are learning. Learning is an evolution process from one step, two step, three step. So we just provide the learning to the student, and according to them, they know they have some concept. They can predict what the value, what the solution they can generate in their future. Similarly, if I'm talking about how child is learning from their childhood, so we know that we see the kids, babies basically when they are grown up. We don't have some machine to train them. They if they are born in USA, they will learn English in their accent. If they are born in India, they have some accent of the Hindi in their language. Similarly, if they are born in some other countries, they have their own accent. They will learn by learning process. We don't have some machine that we fit on the mind of the baby and said that start speaking, start learning. No, we the child basically see the nearby surrounding. वो अपने आसपास के नेबर को ऑब्जर्व करता है, उसने लर्न करता है, उससे अक्षर पकड़ता है, what उससे accent, sound, everything they will pick. The mind collect that and start learning. Okay, this thing in our learning is if I'm talking in Hindi, then baby start learning Hindi. If I'm talking English, my baby start learning. How it's possible? Because mind is developing accordingly. Same thing, the both same thing happened in our soft computing. We provide the learning in each and every step, because initially system is like a baby. We don't have to feed something in their mind. We don't have anything. We just gradually provide something data, some new things, some new concepts, new facts, and by wrapping up them, we produce some sort of the output. And in future, if the same thing has occurred, if same parameters is coming, then the system is now ready. They can generate output according to the situation, the learning they have. So the same manner the soft computing is learned as over the human mind. So that's why we say that I said that it is our role model. So now, if I'm talking about the hybrid computing is a combination of the conventional hard computing and emerging soft computing technology. If I have a one problem related with the hard computing that I need a mathematical model and a answer, and if I want some soft computing approaches that contains approximations, then the combination of these two sets, if I represent it in the this diagram, that one side I have taken the hard computing, on other side I have taken the soft computing. There is a one portion, the both the approaches where our solution or problem mat, and we will discuss that in that area, the hybrid computing world, where we take the some feature of the soft computing, where we take the some feature of the hybrid computing, and we will merge them together, and we will get the perfect, not a perfect, but we will get the solution according to our problem. So now we will discuss the hard computing versus soft computing. So in hard computing, I discussed already with you all, it is precise based on the binary logic, either 0, 1, that means the result should come or not, yes or no. It should be a numerical analysis, completely theorems, proofs are available. They provide the precise result. Hard computing work on the precise result. Input should be the exact data. The exact data should I given, I get the precise exactly result I wanted. Hard computing use two value logic, and whereas have a sequential computation. I cannot jump from the first to last and then I come back in. They have a sequence of the steps. They have to follow that steps. Basically, some sort of the algorithm. They have to follow that. Whereas if I'm talking about the soft computing, it's imprecise based on the fuzzy logic, neural network. The soft computing result approximate results, not exact result, approximate it. If I'm saying the output should be fine, it should be 4.95, 4.8, 4.85.0, and it's all are approximate results. So these are the results. There's not exact result, but they are approximate result. It deals with the ambiguity. There may be the repetition, noisy data. It can deal with this sort of things like multi-valued logics. Whereas I have seen that in hard computing, they use two-valued logic. So soft computing can perform parallel computation. We talk about the sequential, that one step they have to follow, then second, then basically proof or sort of remind terms of hard computing. In soft computing, we can do the parallel computing. If I start one task and I run with that, in the same task, I provide the learning and I get the different solution for the same. So the references for my presentation is from the book Principle of the Soft Computing and from the NPTEL Introduction to the Soft Computing. This is a disclaimer for my video. Thank you all.